Hey everyone, welcome back to Mr. Carroll's Classroom. Today we're going to continue with exponential functions, and specifically we're going to talk about the finance world and how we apply the compounding interest formula. So let's go ahead and get started. Okay, so as far as the finance world goes, we have some main formulas here to talk about. And of course, we're starting, and these are all based off of our standard exponential formula of y is equal to a, some kind of starting point, times b, the base, in which case that's our rate that we're multiplying by, um, all to the power of x. In the finance world, typically this x is going to stand for time, as we'll see here in a second. So the three major formulas, at least that we're going to cover in this particular class, are going to be this first one, which is a is equal to p times 1 plus or minus the rate, and that's whether or not it's increasing or decreasing, all to the power of t. And in this case, actually, let's go ahead and label these real quick. A is going to stand for the final amount. P is going to stand for the principal amount or the starting amount. R is going to be your interest rate, because we're talking about money here. T is going to stand for time, and according to all of these formulas, time is actually going to be in years. Okay? And then we're going to get to this compounding interest formula, which is A is equal to P, the principal, the initial amount, times 1 plus or minus your rate, again, whether or not it's increasing or decreasing, divided by N, which is how many times the rate, the annual rate, is going to be compounded. We'll talk a little bit about what that means in a second. And that's all to the N, again, times t. So the n, the number of times it's going to be compounded per year, times the number of years, which is t. Next lesson, we're actually going to get into this last formula. It's commonly referred to as PERT because it's A is equal to P times E all to the RT. All right, so let's continue on here. So again, today we are going to be concentrating specifically on these two formulas, which are the simple interest formula and the compounding interest formula. Okay, and again, the compounding interest formula, what does it actually mean? Like, what's the difference between simple interest and compounding interest? Well, essentially, all we're really doing is we're taking that rate, right, from the simple formula, and we're going to split that rate up over smaller intervals, okay? Which is why you can see here we have R divided by the number of times we're going to compound it. And then T, since T is specifically in years, then we also have to say, well, if we're going to compound like 4 times per year, for example, that would be N would be 4 times per year, and then T would be 1 for 1 year. So anyways, so we do have to apply N by dividing our rate and also adjusting the amount of times that we're actually going to multiply by this rate as the exponent. Oops. And get rid of this. Okay, so in order to show this, I'm gonna show you two examples. So the first example here is gonna be your simple formula here, which is, hey, we're gonna start with $1,000. Just imagine, it's a savings account or some kind of investment, whatever. But ultimately, we're starting with $1,000, and we're going to apply a 4% annual, and that's really important there, annual, the word annual, interest rate. Annual meaning this percentage is going to be applied on an annual basis, which again, since t is in years, then we can go ahead and use that simple interest formula. And our second example that we're going to compare this to is going to be a compounding example with the exact same starting amount of $1,000 with the exact same annual rate, 4%. However, it's going to be compounded quarterly. Okay, so what does it mean to be compounded quarterly? Well, quarterly essentially means that instead of if we have 1 year as our timeline here, if we're applying the first one, that's just, hey, we're going to apply 4% one time. However, if we're going to compound quarterly, that means we're going to take that 4% and we're actually going to split it up into quarters. So in this case, it's actually every 3 months for a year because there's 12 months in a year. But anyway, and so after the first 3 months, we're going to apply 1% of that rate. Then we're going to again apply another 1%, then another 1%, and another 1%. So that 4% is split up into 4. Okay, and we're going to apply it 4 separate times. All right, so let's go ahead and do this and just kind of see what happens. So the first one is pretty simple, right? So we're just applying the simple formula here, and I'm just going to call this A of t, plugging in time for years. Anyway, so we're starting with $1,000. We're going to multiply by 1 plus the rate because we're increasing. Again, if we were decreasing by 4%, it would be 1 minus that 0.04. But anyway, so we have 1.04 and then all to the power of t in whatever years. Okay, so the next one, if we apply this formula, the compounding formula, right, we're starting with $1,000 and we're going to say 1 plus the rate, which is 4%, and then we're going to divide it by the number of times we're compounding it per year. And if it's quarterly, that means that we are going to split that up into 4 separate compounding, whatever you want to call it. We're splitting it up into 4. Anyways, now the issue is we also have to again adjust our timing here. So we're having it's not just 1 year, or if we're putting in 1 year, we're not going to do this one time. We're actually going to do it 4 times per year. So that's why you get n times t, or 4 times t, 4 times the number of years. Okay. All right, so let's go ahead and actually apply this. So like if we apply this for just 1 year, let's just see what happens if, if we, like, what's the difference, I guess, right? If we just say, hey, we're going to apply 4% rate, we're going to apply that 4% one time versus splitting that 4% into 4 1% installments. Like, is there going to be an actual difference? Well, let's take a look and calculate it. So in this first one, A sub 1, we're going to go ahead, or A of 1, we're going to go ahead and plug in 1 for t for 1 year, and we end up with $1,040. So let's go ahead and see what happens when we actually compound that interest rate. So here we go. We're going to go ahead and plug in 1 for t. All right, so really it's just this one right here that got plugged in. And the solution ends up being pretty close, actually, $1,040, but now we have this additional 60 cents. So it wasn't by much, but actually compounding the exact same rate of 4%, compounding that over a period of 4 times actually increased the amount. So the question is, which one's better and which one's worse? Is it better to compound, or is it better to just use simple interest where we just apply that interest rate 1 time per year? Well, it really just depends on what end of the situation you are on, right? So if, say, for example, you're getting charged an interest rate, right? Then if they're compounding that interest rate, then they're going to charge you a little bit more, right? They're going to squeeze a little bit more out of that. However, at the same time, if, say, this is a savings account, well, which one's better? Well, compounding would definitely be better because you're making more money, right? So it really just depends on which end of the situation you are on. Okay. Now, last thing I want to talk about is that really these two functions are exactly the same, and I've kind of alluded you to that already. But again, this simple interest formula right here is technically the exact same thing as the compounding interest. The only difference is that in the finance world, they typically lock that T in to stand for the number of years. But if we allow T to be any increment of time that we want, let's go ahead and just like rethink this second problem, the compounding interest one. Let's see if we can write this compounding formula using the simple interest formula. So let's go ahead and do it. Now, if we redefine T as not years but quarters, if we think about it in quarters, then we can just use our simple interest formula, right? We can say, okay, well, every time, well, we're not applying 4%, right? Every quarter we're applying 1%. So that's where we get the 1.01 from. So we're going to apply a rate of 1.01, and then t is just going to stand for the number of quarters. So for this particular example, if I was just talking about 1 year, well, there's 4 quarters in 1 year. So obviously I would plug in 4 for t, because t stands for quarters in this case. And I want you to notice that right here, these two are identical. This 1000 times 1.01 to the fourth power, if you simplify this, well, 0.04 divided by 4 is 0.01, getting us 1.01. And up here, 4 quarters times 1 year is 4, which we actually get the exact same thing. So there's not like a secret to this compounding interest formula or anything like that. Really the only reason why it's necessary is because in the finance world, we typically lock in t to stand for the number of years. But if you did allow it to stand for any increment of time that you wanted to, then it really just all comes back to this exact same exponential formula here. A, your starting point, times some kind of b, your base or your rate, all to the power of x, which is going to stand for how many times you're going to multiply by that rate. Okay, let's continue on. All right, so we're going to show one more example here, and actually there's going to be it's going to be one example filled with a lot of smaller examples. Okay, so here's the example. We're going to again start off with $1,000 at 4% interest rate, and this thing is going to be compounded. We're actually going to do all of these. We're going to compound it annually, meaning basically it's just the simple interest formula, right? Once per year. But then we're also going to do semi-annually, which is twice per year, quarterly, which is 4 times per year, monthly, which is 12 times per year, and daily, which is 365 times per year. And the real question I want to try to answer while we're actually practicing this is, if compounding your interest rate actually yields a higher dollar amount, like how high can we go? Can we just compound it at again, maybe every second or something like that, and we just get massive amounts of money? Well, let's go ahead and take a look and calculate these and see what the behavior actually is. All right, so this first one, annually, I'm still going to use the compounding interest formula, but again, it's gonna end up yielding the simple interest formula. But anyway, so in this case, if it's annually, it's just n is 1. So we have 1,000 times 1 plus our rate of 0.04 divided by n, which is 1, and then all to the 1 times t. That's our setup. Our next one, semi-annually, well, n simply changes to 2. So we're going to divide the rate by 2. Okay, and then we're also going to multiply twice per year, so 2 times t. Quarterly, of course, we actually just did that one, right, is 4 times per year, so divide the rate by 4, and then also multiply the time period by 4. Monthly is going to be 12 times, so divide the rate by 12, and then multiply your exponent by 12, your timeline, your time increments. And then, of course, daily is going to be 365, which is our rate divided by 365, some kind of crazy decimal there. And then the amount of times we're going to multiply it is 365 times per year times t. All right, so let's go ahead and take a look. What this is actually going to calculate, we're just going to apply like a random amount of years here. Let's just say we have this savings account or investment, whatever you want to call it. We're going to calculate how much we are going to have after 30 years by applying these different levels of compounding. All right, so here we go. Here are our solutions. And does this spiral out of control? That's the question. Well, let's take a look. Our simple interest, right, just once per year, it yields $3,243.40. Then, once we do it semi-annually, there's a pretty big jump here by almost $40. Okay, $3,281.03. Then when we compound it quarterly, there's actually a smaller jump. So the first jump was about $40. The next jump is only about $20. Then when we compound it monthly, then we get an even smaller jump of about $13. And then when we go to daily, 365 times really it's only about $6 that we're jumping. So is this spiraling out of control? No, it's actually kind of slowing down. Now it is increasing, right? So for an investment or something like that, it is beneficial to have some kind of compounding interest. But does that mean that the more you compound it, you're just gonna get way more money? No, that is not the case. Now, tomorrow we're actually going to talk about what it means to compound continuously. So not daily, not like every second or millisecond, like every instantaneous moment in time. We are compounding continuously. So, and that's what yields our PERT formula. But for now, here we go. There's a couple of examples on how to utilize our compounding interest formula, and then hopefully you'll be able to answer questions with this now, and hopefully this lesson was helpful to you. So anyway, have a good day, and I hope to see you in the next one.